this cosmic wanderer bigger than Manhattan, is drawing closer. 3I Atlas, its trajectory set on a fleeting brush with Mars. A mysterious visitor from the stars, gliding silently through the vast emptiness of space, on a path that will bring it closer to our solar system than anything we've ever witnessed. Moving faster than any comet or asteroid, it carries with it the secrets of a distant galaxy. But what is 3I Atlas? Is it just a comet? Or could it be something far more extraordinary? Perhaps something artificial, an artifact, or even a probe sent from a distant civilization. As 3I Atlas races toward its closest encounter with Mars, the questions grow. Is it a relic from a long-forgotten star system, drifting in from the farthest reaches of the universe? Or does it carry with it a message, a sign of intelligence beyond our understanding? For months, the world's most powerful telescopes have been trained on it, capturing fleeting glimpses as it draws nearer, but each answer only sparks more questions. Its speed, its strange composition, its unexpected behavior. Nothing about 3I Atlas fits into the categories we are familiar with. What we do know is this. This visitor from the stars is unlike anything we've ever encountered. October 3rd will be the day when 3I Atlas makes its closest approach to Mars, passing just 29 million kilometers from the red planet. It's a moment that has been anticipated for months. But will it reveal the secrets it holds? Or will the mysteries deepened by its presence leave us more captivated than ever before? It is not just another comet. It is a cosmic event, a brief but powerful encounter with the unknown, a chance to peer into the mysteries of space, and perhaps, just perhaps, discover something that challenges everything we thought we knew about the universe. On July 1st, 2025, 3I Atlas was detected by NASA's Atlas telescope in Chile. This was the first time an interstellar object was identified as a comet passing through our solar system. Initially catalogued as A11PL3Z, the object was soon confirmed to be an interstellar visitor. It came from a star system beyond our own, traveling at speeds we've never observed before. But as scientists studied it further, they realized it wasn't just another comet. It was something extraordinary, something that would challenge everything we knew about celestial objects. This is the third confirmed interstellar object to pass through our solar system, following Oumuamua in 2017 and 2I Borisov in 2019. Unlike Oumuamua, which sparked wild theories about its origins due to its strange shape and erratic behavior, and 2I Borisov, which behaved like a typical comet, 3I Atlas breaks new ground. Its speed, composition, and size are unlike anything we've seen before, making it one of the most intriguing objects to pass through our solar system. The most remarkable feature of 3I Atlas is its hyperbolic trajectory. Unlike typical comets that follow elliptical orbits and return to the solar system periodically, 3I Atlas is on a one-way journey. It's not bound by the sun's gravity. After it passes Mars, it will continue on its path out of the solar system, never to return. This is a true interstellar visitor, a wanderer from another star system, making a brief appearance in our solar system before continuing its journey into the vast unknown. It's traveling at 130,000 miles per hour, 3 times faster than the fastest spacecraft we've ever sent, including Voyager 1, which travels at 35,000 miles per hour. Imagine the speed of this object as it tears through space. To give you some perspective, that's like a car moving at the speed of sound 3 times over, almost beyond comprehension. If we could somehow harness its speed, it would only take 8 minutes for 3I Atlas to travel the distance from Earth to the Moon, a feat that would take our fastest spacecraft over 12 hours. But it's not just its speed that's remarkable, it's also its size. It is estimated to weigh around 33 billion tons, making it one of the heaviest interstellar objects ever observed. For context, that's equivalent to 1.5 million fully loaded Titanic ships. If we wanted to imagine just how big it is, think of it as the size of 3 Empire State Buildings stacked on top of each other. That's how massive this object is, racing through space at incomprehensible speeds. If it were to collide with Earth, which is extremely unlikely, the impact would be catastrophic. The explosion would release an energy equivalent to millions of atomic bombs, capable of creating an impact large enough to reshape the planet. Fortunately, it will pass close to Mars, coming within 29 million kilometers, but it will never pose a direct threat to Earth. This brief encounter with the solar system presents a once-in-a-lifetime opportunity to study the object in unprecedented detail. Now, as it approaches Mars, scientists are turning their telescopes and spacecraft toward it, hoping to unlock the mysteries it holds. Early spectroscopic data from James Webb Space Telescope and SphereX revealed that 3I Atlas has a coma rich in carbon dioxide, along with carbon monoxide, water ice, and even cyanide. This composition is far more complex than the simple water ice found in typical comets, suggesting that 3I Atlas originated in a cold region far from its parent star. The fact that it contains carbon dioxide, a gas that typically exists on comets only when they get closer to the Sun, is one of the many anomalies about this object. The presence of carbon monoxide and cyanide compounds is even more telling. These are chemicals that form in low-temperature environments, adding to the growing body of evidence that it comes from a distant, ancient star system, possibly from a part of the Milky Way known as the thick disk, where metal-poor stars dominate. The most intriguing discovery, however, came when nickel was detected in the coma of 3I Atlas. Nickel is a metal typically found in asteroids, not comets. And not only was nickel found, but it was unaccompanied by iron, which is highly unusual. This raises many questions. Could it be a metal-rich comet, one that formed in a star system with high metallicity? Or, as some have speculated, is it something else entirely, something artificial? As more data came in, astronomers turned to the Very Large Telescope, which observed 3I Atlas and found an extreme negative polarization in its coma, a feature reminiscent of trans-Neptunian objects, which are known to be highly reflective. This suggests that 3I Atlas could have a surface composition unlike any other comet we've seen, with material properties that could change how we understand comets and even objects from outside the solar system. In the scientific community, there are two major schools of thought. One believes that it is a natural comet, a relic from another star system that formed under different conditions. But there are also those who, like Avi Loeb, believe that 3I Atlas could be an alien artifact, possibly even a probe sent to explore our solar system. Loeb, a professor of science at Harvard University, has been vocal about the idea that 3I Atlas might not be a comet at all, but instead an artificial object, designed and sent by an advanced civilization. Loeb argues that the extreme speed of 3I Atlas, far faster than any known comet, combined with its unusual composition and metallic features, points to a man-made origin. The idea is that it could be a probe sent to explore our solar system, much like how we send satellites and spacecraft to other planets. It's a provocative theory that has sparked much debate in the scientific community, especially since 3I Atlas doesn't behave like anything we've ever seen. But for now, the theory remains just that, a theory. Most scientists believe that it is simply a rare and extraordinary comet from a star system far beyond our own. However, its strange behavior and unique composition leave the door open for speculation. Is it a comet? Or is it something else entirely? On October 3rd, 2025, 3I Atlas will pass just 29 million kilometers from Mars, offering the first close-up opportunity to observe this cosmic wanderer. Space agencies around the world, including NASA, ESA, and the European Space Agency, are preparing for this flyby. Mars Express, ExoMars, and Mars Reconnaissance Orbiter will gather high-resolution images and spectral data, providing the best insight into what 3I Atlas really is. October 3rd, will mark a pivotal moment. For the first time, scientists will have the opportunity to observe this object in incredible detail, and the data gathered could be groundbreaking. Will 3I Atlas reveal its secrets? Will we discover that it's simply a comet? Or could it provide evidence of a far more mysterious origin? One that could change our understanding of the universe itself. The flyby will allow us to see this interstellar object in ways we've never seen before. It's a moment of discovery, a moment that could define how we look at the cosmos. October 3rd is not just another date on the calendar. It's the day we might uncover the truth about 3I Atlas. October 3rd is fast approaching, and the flyby of 3I Atlas could change everything we know about comets, interstellar objects, and even the possibility of extraterrestrial life. But before we continue, pause for a moment and hit that like and subscribe button if you're as curious as we are about what this interstellar wanderer will reveal. And hey, drop a 3I Atlas in the comments if you're eager to stay updated on all the exciting discoveries coming our way in the next few days. Before we dive into the timeline of 3I Atlas and its historic flyby of Mars, let's take a step back. What if we told you that the object hurtling through our solar system could be more than just a comet? What if it's not just a natural phenomenon but something far stranger? Something from an alien civilization? Could this be the first undeniable evidence that we're not alone in the universe? The theory that 3I Atlas could be a probe or artifact from an alien civilization has been brought to the forefront by Avi Loeb, an astrophysicist from Harvard University. Loeb is best known for his controversial stance on Oumuamua, the first interstellar object to be observed in 2017. He proposed that Oumuamua might have been a piece of alien technology, and the idea raised eyebrows across the scientific community. But now, with 3I Atlas, Loeb's theory seems more relevant than ever. What makes Loeb's theory so compelling is the way 3I Atlas defies the natural patterns we've come to expect from interstellar objects. Most comets and asteroids follow predictable orbits and behaviors, but 3I Atlas does not. Its speed, its comet-like tail, and its unusual composition, particularly the presence of nickel without iron, lead to speculation that it could be artificial. After all, nickel is rare in natural comets and is often associated with metal-rich asteroids or human-made objects. Nickel and iron are typically found together in metal-rich objects like asteroids, and their presence in it is certainly intriguing. But the absence of iron in its composition, particularly when compared to known comets, raises more questions. Could this be evidence that it is a piece of technology, either naturally occurring or intentionally designed? That's the core of Loeb's theory. 3I Atlas may not be just another comet. It might be something more, a probe or artifact sent by a far-off civilization, possibly a long time ago. But Avi Loeb isn't the only one suggesting the possibility of alien intervention. The WOW signal discovered in 1977 also plays into this narrative of alien mystery. For those unfamiliar, the WOW signal was a radio signal detected by Dr. Jerry Eman at the Big Ear Radio Telescope in Ohio. It was a bizarre, unexplained radio signal that lasted 72 seconds with no clear source identified. It was a discovery that made headlines and has puzzled scientists for decades. Could the WOW signal be evidence of alien technology? Could the WOW signal be a signal from the same advanced civilization that might have sent 3I Atlas? Is it a coincidence that both 3I Atlas and the WOW signal have stirred the same questions about the existence of extraterrestrial life? The WOW signal isn't the only instance of mysterious signals and objects pointing to alien possibilities. In fact, scientists have been observing strange phenomena in our solar system for years. One prominent theory has emerged from SETI, Search for Extraterrestrial Intelligence, which posits that extraterrestrial civilizations may use objects like 3I Atlas as scouts or messengers, a means of transmitting data or signals. As our technology advances, we may begin to uncover even more objects that behave in ways that our current understanding of space and physics cannot fully explain. Could it be the first piece of physical evidence that extraterrestrial intelligence exists? What makes speculation like this so compelling is that it forces us to ask bigger questions. It challenges our understanding of what is possible in the universe. It reminds us that science isn't just about answers, it's about curiosity. The more we speculate, the more we learn. Speculation is the fuel that propels scientific progress, even if that speculation feels far-fetched. Could 3I Atlas be evidence of alien intelligence? Could it be a scout or a probe sent to explore our solar system? Or is it simply an unusual natural phenomenon that we don't yet fully understand? What's most interesting about 3I Atlas is how it raises more questions than it answers. And that's where the intrigue begins. If it's truly a probe, then where did it come from? How old is it? Could it have traveled through our solar system millennia ago, unnoticed until now? Could this be the first physical evidence of interstellar intelligence? And if so, what else might be out there in the cosmos? What adds another layer to this mystery is the WOW signals connection. When it was detected in 1977, it puzzled scientists because it came from deep space, with no clear source, and with such specific frequency characteristics that it seemed almost unnatural. Some scientists even speculated that the signal was not a random cosmic event but a message from an alien civilization. If it is indeed an artificial object, could it be connected to similar signals we've seen? Could there be a larger cosmic communication network we're only beginning to understand? Speculation drives our search for answers. Without it, science would be stagnant. It's theories, questions, and even hypotheses that open the doors to new discoveries. And while we won't know the truth about 3I Atlas until we get closer to it, the very fact that we're asking these questions is what makes science so exciting. In a way, it's this mystery that keeps us moving forward. As we continue our exploration, it's important to remember that 3I Atlas isn't just an anomaly. It could be a signpost leading us to something far more significant. Its strange composition, its unexpected speed, and its bizarre behavior only serve to remind us that the universe is far more mysterious than we've ever realized. Could we be on the brink of discovering the first evidence of alien technology? Could it be the first interstellar message that we've stumbled upon? Or is it just another cosmic wanderer, following the laws of physics and gravity, devoid of any higher purpose? Now, before we get ahead of ourselves, let's take a look at the timeline of 3I Atlas and its flyby of Mars, which is just a few days away. October 3rd, 2025 will be the date when we have our first real opportunity to observe this mysterious object in high resolution. What will we find? Could this flyby provide critical data to help answer all these questions? Whatever we find, one thing is certain. 3I Atlas will mark a significant moment in the history of space exploration. It's not just about studying a comet. It's about opening our minds to the possibilities of what exists beyond our understanding. 3I Atlas was first detected on July 1st, 2025 by NASA's Atlas telescope in Chile. At the time, it was still well beyond the orbit of Jupiter, slowly moving through the outer reaches of the solar system. Its speed immediately stood out, much faster than any typical comet or asteroid, and its trajectory was hyperbolic, confirming that it was an interstellar object, here for a single passage through our solar system. Early observations noted a faint glow and the beginnings of a coma, which was unusual for an object so distant from the Sun, suggesting that some sublimation was already occurring far earlier than expected. By August 2025, 3C Atlas had travelled closer to Saturn, and astronomers were able to observe more detailed changes in its coma and tail. Its size was estimated at roughly 33 billion tons, comparable in mass to a mid-sized asteroid, roughly the size of Manhattan in volume if compressed, but with far less density. Instruments aboard ground-based telescopes recorded its increasing brightness, while infrared measurements revealed that the outer layer was releasing carbon dioxide, with traces of water vapor and dust. The comet's tail had begun to form, extending hundreds of thousands of kilometers, and unusual behavior was observed. The tail showed asymmetries, likely caused by interactions with the solar wind, unlike any standard comet observed in our system. By September 2025, 3I Atlas had crossed Mars's orbital plane and was rapidly closing in on the red planet. Observatories worldwide were coordinating through the International Asteroid Warning Network to track its precise path. Distances from Mars were shrinking daily, starting from approximately 0.3 AU, 45 million kilometers, at the beginning of the month. The comet's velocity relative to Mars was climbing steadily, reaching around 25 to 27 km per second as it approached the closest point. Observations noted that its coma continued to grow, and variations in gas emissions suggested active sublimation likely influenced by the increasing solar radiation. On October 1st, the comet was about 42 million kilometers from Mars. This was the point at which orbiters like ESA's Mars Express began wide-field scans to establish the shape and density of the coma, while NASA's Mars Reconnaissance Orbiter initiated pre-flyby calibrations. Data indicated that dust grains within the coma were surprisingly large, up to millimeter-sized, hinting at a composition that could withstand solar heating and strong solar winds. By October 2nd, the comet had closed to 34 million kilometers from Mars. Its apparent magnitude was improving, and the ExoMars Trace Gas Orbiter started monitoring gas emissions, specifically carbon dioxide and cyanide radicals, which had spiked in activity compared to earlier observations. Slight elongation in the tail was being observed, caused by interactions with solar wind, and amateur astronomers reported faint anti-tail structures stretching over 100,000 kilometers. Models suggested that Mars itself would feel negligible gravitational influence from 3I Atlas, though interactions with its ionosphere might create faint auroral effects. The closest approach, on October 3rd, saw 3I Atlas pass within 29 million kilometers of Mars. This was the pinnacle of observational opportunity. Spacecraft including Mars Express, ExoMars and MRO focused their instruments for a concentrated period of high-resolution imaging. Stereo images of the nucleus and coma were taken, potentially resolving plumes or jets up to 10 km per second. Measurements of volatile emissions, carbon dioxide, cyanide, and trace organics were captured during the narrow sweet spot observation window. Data relayed to Earth began streaming, providing near real-time insights into the object's behavior, structure, and interactions with solar radiation. After the flyby, on October 4th, 3I Atlas had moved slightly away, allowing orbiters to pivot toward coma dynamics and tail evolution. Infrared mapping provided data on sublimation rates, which were estimated at 1029 molecules per second due to increasing solar heating. Observations suggested subtle asymmetries in gas release, possibly caused by the close Mars approach altering outgassing vectors. By October 5th, the focus shifted to long baseline measurements. Trace organics were monitored, and thermal infrared imaging measured the nucleus at around 200 K, consistent with active sublimation at this distance from the Sun. Polarimetric studies from ground. Telescopes confirmed large dust grains and the reddish hue typical of interstellar objects. Entering our system, on October 6th, instruments shifted back to wide-field modes, monitoring plasma interactions as the comet's tail extended outward. Ionized particles from the tail were captured by Mars Express's Aspera 3, potentially detecting novel interactions with the Martian magnetotail. Brightness peaked around magnitude 11.8, but decreasing solar elongation limited visibility from Earth. Finally, On October 7th, 3i Atlas completed the week-long flyby, moving beyond 0.32 AU, 48 million km, and beginning its outward journey toward the Scorpius constellation. Observations noted the tail had reached approximately 500,000 km with no significant fragmentation detected. Preliminary analyses confirmed that its structural integrity held, providing valuable insights into the durability of interstellar objects under the influence of both planetary gravity and solar radiation. This week-long timeline provides a comprehensive view of 3i Atlas's journey through the inner solar system. Starting from Jupiter's orbit to its close shave with Mars, each day has offered incremental discoveries about its composition, behavior, and physical properties. The October 3rd flyby stands out as the most critical observation window, giving humanity the chance to capture unprecedented data on an interstellar traveler. Beyond Mars, 3i Atlas will continue toward its perihelion, where additional observations will refine our understanding of how objects from distant star systems interact with solar radiation, planetary gravity, and interstellar space itself. This timeline not only charts the movement of 3i Atlas, but also highlights the scientific significance of its passage. The first high-resolution observations of an interstellar object near a planetary body, the ability to measure its mass and composition, and insights into how hypervelocity interstellar objects survive their journeys through foreign star systems. Each observation contributes to a growing narrative about interstellar visitors, their composition, and the dynamics that govern their motion, setting the stage for future studies of similar cosmic travelers. By October 3, 2025, we will finally have the opportunity to understand what 3i Atlas truly is. This is a pivotal moment in space exploration. For months, scientists have speculated about this interstellar wanderer, its unusual composition, and its strange behavior. After its closest approach to Mars, which brings it to just 29 million kilometers away, we'll have the first real opportunity to observe 3i Atlas in high resolution. What will we find? Could this be the first undeniable evidence of extraterrestrial intelligence? Or is it just another comet from the depths of space? As 3i Atlas passes Mars, it will reveal crucial data that will help us decipher its mysterious nature. For one, scientists will be closely observing the nucleus, the heart of the comet. This is where the bulk of its mass lies. How big is it? What does it look like? Is it smooth like most comets? Or is it irregular, with jagged edges or craters? Typically, the nucleus of a comet is a mixture of water ice, frozen gases, and dust, an object that seems fragile as it hurtles through space. But this object, 3i Atlas, doesn't behave like any comet we've observed before. It's speeding through space at an incredible rate, faster than any comet or asteroid we've encountered. With its hyperbolic trajectory, it is not bound by the sun's gravity. It's simply passing through, headed on a one-way journey into the stars, never to return. Scientists have never had the chance to study such an object this closely. The images captured during the flyby could provide valuable clues about the nucleus's composition and, more importantly, its origin. If it's just an ordinary comet, then why does it show such unusual features? Could the composition of the nucleus give us a clue about where it came from and what it's made of? Next, the chemical composition of 3i Atlas will be a key focus. From the data gathered so far, it's clear that 3i Atlas has some unique characteristics. One of the most interesting findings is the presence of nickel, a metal that's rare in comets. But what's even more puzzling is that the nickel is found without any iron, a combination that doesn't fit with what we would expect from natural comets. Nickel is often associated with metal-rich asteroids, and the presence of this metal without iron has led to the idea that 3i Atlas could be something more than a natural comet. Could it be artificial? A probe sent by an alien civilization? Or is it just an anomaly? A rare natural occurrence that doesn't fit within the usual patterns we expect to see. On October 3rd, the Mars Reconnaissance Orbiter will begin capturing high-resolution images of 3I Atlas's nucleus. Using the high-rise camera, MRO will take images with a resolution of about 100 meters per pixel, allowing scientists to study the details of the nucleus. Will it have the typical dirty snowball appearance, or will it show signs of something more sophisticated? This is the kind of detail that could help us understand the true nature of this interstellar object. Along with these images, scientists will also be using spectrometers on Mars Express and ExoMars to analyze the outgassing from the Comet, the cloud of gas and dust that surrounds the nucleus. As the comet approaches the Sun, the ice in the nucleus begins to sublimate, creating a cloud of gas and dust. This process, known as sublimation, provides a wealth of information about the object's composition. What gases are being emitted? How does the tail form? And what does it tell us about the comet's internal structure? These are the kinds of questions scientists are eager to answer. As the comet approaches Mars, the tail development will also be a major focus of study. Typically, the tail of a comet is formed when gas and dust are released from the nucleus due to solar heating. The gas is ionized by the solar wind, and it forms a glowing tail that always points away from the Sun. But 3I Atlas has shown unusual behavior when it comes to its tail. Scientists will be watching to see if the tail behaves differently from what we would expect. Could this be another clue to its origins? The solar wind will play a role in shaping the tail, and by observing how it forms, scientists could learn about the forces acting on 3I Atlas as it travels through the solar system. The fact that it's already showing some unusual characteristics, like its nickel-to-iron ratio, adds even more intrigue to the tail's formation. Will it behave like a typical comet, or will it break the mold entirely? The Flyby on October 3rd is just the beginning of our investigation into this interstellar traveler. Once it passes Mars, it will continue on its journey toward the Sun. But the data collected during this flyby will be invaluable for our understanding of interstellar objects. Will it confirm that 3I Atlas is just another comet, an object from another star system that's traveled for millions of years, passing through our solar system without much consequence? Or will it reveal something more, something that could change the way we think about the universe and our place in it? The flyby will offer us the first real opportunity to study 3I Atlas in great detail, and the findings could be groundbreaking. As we await October 3rd, we can only speculate about what we'll discover. Will this be the first time we find concrete evidence of alien technology? Or will it be just another cosmic wanderer, no different from the many others that have passed through our solar system? Whatever we learn, one thing is clear. This flyby will open new doors for our understanding of the universe. It will allow us to peer into the unknown, to ask bigger questions, and to make new discoveries that will shape the future of space exploration. And while we may not have all the answers just yet, the journey of 3I Atlas will undoubtedly take us one step closer to understanding the vast mysteries of the cosmos. As we count down to October 3rd, 2025, we are reminded that science is a journey that doesn't end with answers, but continues with questions, speculation, and discovery. This is the excitement of exploring the unknown, and the closer we get to 3I Atlas, the more we will uncover about the universe beyond our reach. What we learn from 3I Atlas could set the stage for a new era in space exploration and scientific discovery, the search for alien life, the study of interstellar objects, and the quest to understand the origins of our own solar system. These are all intertwined in the cosmic journey of 3I Atlas. As we await the first data from the flyby, one thing is certain: the answers we find will only lead to more questions. And that's what makes space exploration so thrilling. The mysteries are infinite, and the discoveries are just beginning. The arrival of 3I Atlas has not only captured the imagination of astronomers and space enthusiasts alike, but also deepened the mystery. surrounding two of the most profound questions in astrophysics, the Drake equation and the Fermi paradox. This interstellar wanderer, a comet-like object speeding through our solar system, might be the key that unlocks a new understanding of extraterrestrial life, communication, and intelligence. The questions posed by these paradoxes are as old as modern astronomy itself, and yet 3i Atlas offers us a unique opportunity to explore them in ways we never thought possible. The Drake equation and its assumptions. The Drake equation, formulated by astrophysicist Frank Drake in 1961, serves as a way to estimate the number of technologically advanced civilizations in our galaxy capable of communication. It is based on factors such as the rate of star formation, the fraction of stars with planets, and the likelihood of life evolving on those planets. Perhaps most importantly, the equation is built on the assumption that any advanced civilization would produce signals, radio waves or other detectable emissions, that we could pick up. The equation is a hopeful tool, suggesting that intelligent life is out there waiting to be discovered. However, the equation is also grounded in the idea that intelligent life communicates through electromagnetic waves, which is something we understand well, having built our own communication systems based on similar principles. But what if the reality is vastly different from our assumptions? What if intelligence doesn't express itself in ways we can recognize? Could it be that the signals we're looking for, the ones we expect to hear, are not the right kind of signals? Could 3i Atlas, the first interstellar object discovered to pass through our solar system, be the first evidence that intelligent life might be entirely different from what we imagine? 3i Atlas has forced us to consider that extraterrestrial intelligence might not communicate in the ways we expect. Instead of sending signals or radio waves across vast distances, what if advanced civilizations sent probes, interstellar objects, much like 3i Atlas itself? This opens the door to a new kind of communication, one not reliant on electromagnetic signals, but rather on physical artifacts traveling through space. Perhaps intelligent civilizations send objects, much like we send our own probes like Voyager and New Horizons, as emissaries across the galaxy. The discovery of 3i Atlas, with its strange behavior, composition, and unexplained features, has added weight to this theory. Could this be an interstellar probe, not meant to be observed directly by us, but rather just passing through our solar system on its journey? If so, it challenges our understanding of the Drake equation. If extraterrestrial intelligence uses artifacts like 3i Atlas to explore, we would have to rethink the entire equation, especially in terms of the methods by which we detect extraterrestrial life. The Fermi paradox. Where are they? The Fermi paradox presents a simple but profound question. Given the vast number of stars and planets in the universe, why haven't we encountered any evidence of extraterrestrial life? Statistically speaking, the odds are overwhelmingly in favor of the existence of intelligent life elsewhere in the galaxy. However, despite the odds, we have yet to find concrete evidence of other civilizations, whether through signals or physical artifacts. This paradox has baffled scientists for decades. If life is as common as the Drake equation suggests, why haven't we found any signs of it? The 3i Atlas flyby adds yet another layer of complexity to this paradox. What if the Fermi paradox isn't about the lack of intelligent life, but rather the inability to detect it? What if extraterrestrial civilizations are sending objects, much like 3i Atlas, that we cannot recognize or detect as being of intelligent origin? The strange nature of 3i Atlas is, in some ways, the perfect embodiment of the Fermi paradox. Here we have an object that is clearly from another star system, a visitor from deep space, but it's not immediately clear whether it's natural or artificial. If it's a probe, we might be looking at evidence of alien intelligence for the first time. However, the fact that we're unsure raises more questions than answers. Could this be the first tangible evidence that we have for all intents and purposes, missed alien civilizations that have been sending out probes across the galaxy for eons. Could 3i Atlas be a messenger of sorts? Something that points to the larger cosmic presence of intelligent life. If 3i Atlas is indeed artificial, or even if its origins are related to alien technology, it suggests that we may have been searching for the wrong signs. Instead of searching for radio signals or electromagnetic waves, perhaps the evidence of extraterrestrial intelligence is hidden in plain sight, in the form of physical objects passing through our solar system or other star systems. The discovery of 3i Atlas forces us to reconsider the Drake equation. If interstellar objects are indeed probes or evidence of past civilizations, we may need to adjust the parameters of the equation. We may have been looking for radio signals and electromagnetic emissions, assuming that intelligent life would communicate in familiar ways. But the presence of 3i Atlas could mean that we've been looking in the wrong direction altogether. Imagine, if you will, that instead of focusing on signals, we should be focused on artifacts. What if these interstellar visitors are not just passing through, but are sent deliberately, like postcards from another time and place, meant to be discovered by advanced civilizations? If this is the case, then 3i Atlas might just be the first such artifact to be encountered, providing us with an unprecedented opportunity to understand how intelligent life could communicate without direct signals. The fact that we have only just begun to detect these interstellar objects suggests that perhaps the universe is full of such probes, and we simply haven't had the means to recognize them. If 3i Atlas is an emissary from a distant civilization, it opens the possibility that we could find more such visitors in the future. And what would that mean for the Drake equation? Would we need to revise it to account for these artifacts rather than just signals? The bigger questions. What if 3i Atlas is a probe? If 3i Atlas is a probe or an artifact, where did it come from? What civilization could have sent it? And how long has it been traveling through space? These are questions that lie at the heart of the Fermi paradox. If 3i Atlas is a probe, it's possible that it has been traveling for millions, if not billions, of years. Perhaps it has passed through numerous star systems, but only now in our time are we able to detect it. What's also fascinating is that the possibility of alien probes doesn't just change the nature of the Fermi paradox, it shifts the paradigm of space exploration altogether. Instead of focusing on detecting signals, we might need to focus on detecting these postcards, artifacts that reveal a civilization's presence across the galaxy. And if 3i Atlas is indeed a probe, it suggests that we may not be alone, and that there are many others who have ventured out into the universe, sending probes to explore faraway star systems. As the world's leading space agencies prepare for the flyby of 3i Atlas, the question that looms large is whether this will be our first definitive evidence of extraterrestrial intelligence, or if it will simply be another mystery in the long history of space exploration. We won't know for sure until we gather more data, but what's clear is that 3i Atlas is much more than just a comet. It's a glimpse into the unknown, a potential window into alien intelligence, and a critical piece in the puzzle of understanding our place in the cosmos. The Fermi paradox and 3i Atlas. What does it mean for us? The discovery of 3i Atlas challenges our assumptions about the nature of extraterrestrial life. It forces us to confront the Fermi paradox head-on, asking the question, if intelligent life is out there, why haven't we found it? Could it be that we are simply looking for the wrong things? Or is it that alien civilizations are using methods of communication far beyond our current comprehension, leaving us to detect only their artifacts and not their signals? As we approach the moment when 3i Atlas makes its closest pass to Mars, the world's eyes are turned toward this interstellar visitor, eager to learn whether it will answer some of the greatest questions of all time. Will this flyby bring us closer to the answer to the Fermi paradox, or will it only deepen the mystery, leaving us to continue our search for signs of intelligent life elsewhere in the universe. Non-gravitational acceleration, a cosmic puzzle, the flyby of 3I Atlas, presents a captivating opportunity not only to understand an interstellar object's journey, but also to explore deeper questions regarding the physics of comets and interstellar objects, ISOs. While most comets are governed by the gravitational forces of the Sun and other celestial bodies, some exhibit behaviors that deviate from the norm, particularly in their acceleration. Non-gravitational acceleration refers to the subtle changes in the trajectory of a comet or asteroid that aren't due to the gravitational pull of nearby objects. Instead, these changes are attributed to other forces, primarily outgassing and thermal effects. Outgassing occurs when a comet's ices and volatile materials vaporize due to solar heating, creating jets of gas that act like small thrusters. This can result in tiny, yet detectable changes to the object's speed and trajectory. The most famous example of non-gravitational acceleration is 2I Borisov, the second interstellar object we encountered, which veered off its predicted path by about 0.1 mm s2. The same phenomenon was observed with other comets, but 3I Atlas offers a fascinating case because of its massive mass, approximately 33 billion tons. Scientists have been monitoring this object closely to determine if it exhibits any signs of non-gravitational acceleration. As of now, there has been no observable deviation from the expected path that would indicate any non-gravitational forces at play. However, the flyby on October 3, 2025 could change this. During this peak observation window, scientists will be monitoring for subtle changes in the comet's velocity using instruments like ESA's Mars Express, Mars Radio Experiment, and NASA's Mars Reconnaissance Orbiter's MRO accelerometers. If any discrepancies are detected, say, an unexpected burst of acceleration from the comets, jets, or a sudden anomaly, this could provide groundbreaking insights into the internal dynamics of 3I Atlas. The possibility that this comet may possess a more fine-tuned structure, like Loeb's 410 anomaly scale, could open up new theories about interstellar objects and their potential artificial origins. While these hypotheses remain speculative, the lack of any detected non-gravitational forces in 3I Atlas's movement so far hints at the object's high density. A dense core could absorb the energy from solar radiation in such a way that it reduces the chances of outgassing influencing its motion. This would be a crucial finding, reinforcing the idea that 3I Atlas might not be the typical wandering comet we are familiar with. The WOW signal in 3I Atlas. Strange coincidences? The mystery deepens when we bring in the famous 1977 WOW signal, one of the most perplexing and tantalizing clues in the search for extraterrestrial intelligence. Detected by Dr. Jerry Amon at Ohio State University's Big Ear Radio Telescope in 1977, the WOW signal was a brief, unexplained radio transmission that lasted for 72 seconds, with no clear source identified. Its name, WOW, came from Amon's reaction as he marked the signal on the printout. Despite years of speculation and numerous searches, the WOW signal remains one of the biggest unsolved mysteries in radio astronomy. Could it have been an artifact of alien communication, or perhaps a cosmic anomaly that we have yet to explain? 3I Atlas adds an intriguing layer to this puzzle. According to Avi Loeb, the Harvard astrophysicist known for his work on Oumuamua, 3I Atlas's trajectory aligns eerily with the path of the WOW signal. While the WOW signal originated from a region in Sagittarius, 3I Atlas's path, as calculated from its position in space, is said to coincide 99.4% with that same region. While this alignment is statistically minimal, it certainly fuels further speculation. Could 3I Atlas have been the object behind the WOW signal? Is it possible that the signal itself came from the object, or was it a flare of activity, perhaps from an advanced civilization's communication efforts? The theory that 3i Atlas might be a probe or artifact sent by an alien civilization is bolstered by this coincidence. It would suggest that the WOW signal might not have been a random burst but an actual interstellar message received by Earth decades ago, perhaps as a beacon or a signal from a far-off unknown intelligence. And if the signal was indeed associated with 3i Atlas, then the implications are staggering. Could we be standing on the cusp of discovering our first physical evidence of intelligent life beyond Earth? While this connection is purely speculative, it raises important questions. Could we be too quick to dismiss the possibility of alien technology? Might objects like 3i Atlas serve as scouts, sent out to explore new star systems, just as humanity has sent probes to other planets and beyond? The Fermi paradox. Why haven't we found extraterrestrial life? If 3i Atlas were indeed a probe sent by an extraterrestrial civilization, it would challenge the very heart of the Fermi paradox. The contradiction between the high probability of extraterrestrial life in the universe and the lack of evidence for or contact with such civilizations. The Fermi paradox has perplexed scientists for decades. Given the enormous number of stars in the Milky Way and the high likelihood of habitable planets, why haven't we found any concrete evidence of life beyond Earth? The theory of 3i Atlas as a probe potentially provides a compelling answer to this paradox. Could it be that intelligent civilizations, instead of broadcasting signals that we expect to detect, are using more subtle methods to explore the universe? Perhaps the focus should not be on searching for electromagnetic signals, but rather on searching for the evidence of these interstellar probes. Objects like 3i Atlas that pass through our solar system, leaving subtle clues about the advanced civilizations that sent them. While this theory is speculative, the fact that 3i Atlas has passed through our solar system undetected until now suggests that the universe may be filled with similar objects traveling between star systems. If these objects are indeed probes, then the problem isn't that extraterrestrial life doesn't exist. It's that we haven't been looking in the right way. We've been focusing on signals, while the real evidence may be moving quietly through space, just beyond our detection capabilities. Atlas challenges us to rethink our assumptions about the search for extraterrestrial life. The traditional focus has been on detecting signals, radio waves, electromagnetic emissions, or light signals from distant planets. But what if this is the wrong approach? What if the extraterrestrial life we are looking for isn't sending signals at all? What if they're sending physical objects, probes, artifacts, or even entire civilizations' remains through space? The discovery of 3i Atlas serves as a potential paradigm shift in the way we search for intelligent life beyond Earth. It suggests that, rather than seeking electromagnetic signals, we should also be looking for artifacts, objects that might be far more subtle, more intricate, and perhaps even more common than we think. This changes everything. What if the evidence we're seeking has been floating past us all along, unnoticed? The flyby of 3i Atlas offers an unprecedented opportunity to reframe our thinking about extraterrestrial intelligence. Could it be that the first physical evidence of intelligent life is not a message, but a spacecraft? Could 3i Atlas be the first interstellar probe we've encountered? And what does that mean for our understanding of life in the universe? As the flyby of 3i Atlas draws near, we are faced with one of the most profound questions in human history. What is it? Where did it come from? And what does its presence in our solar system mean for the future of space exploration? The answers to these questions may not come easily, but the discovery of 3i Atlas is already reshaping the way we think about the cosmos. It forces us to confront the unknown and to ask the questions that drive scientific progress. As we wait for the data from the Flyby, one thing is certain: 3I Atlas will forever change the way we look at the universe and our place within it. As October 3rd, 2025 draws nearer, the focus intensifies on 3I Atlas, an interstellar object racing toward Mars, with a potential collision or flyby that could reveal secrets of the cosmos. But what would happen if 3I Atlas actually collided with Mars? First, let's consider the size and velocity of this cosmic wanderer. 3I Atlas weighs approximately 33 billion tons and has a diameter ranging from 0.32 kilometers to 5.6 kilometers, depending on its composition and observations. Traveling at a staggering 27 kilometers relative to Mars, the kinetic energy of this object is unimaginable. The collision of such a massive object with Mars would result in catastrophic consequences. Imagine the scale of the explosion. For context, the Chelyabinsk meteor, which exploded over Russia in 2013, was around 13,000 tons in mass and released energy equivalent to approximately 470-500 kilotons of TNT. Now, 3I Atlas weighs 33 billion tons, which means the explosion from such a collision would be orders of magnitude greater. The resulting blast would dwarf any known meteor impact, likely releasing an energy similar to that of a massive thermonuclear bomb, enough to vaporize significant portions of Mars's surface. The immediate effects would be profound. Massive craters would form, and depending on Mars' geological makeup, there could be earthquake-like tremors across the planet. If there were surface water, though none is currently known, it could trigger tsunamis that would inundate any coastline. The explosion would throw dust and debris into the atmosphere, which could potentially block out sunlight for weeks, creating a planet-wide darkness. Such an event would have an enormous impact on Mars's already fragile atmosphere. The thermal energy from the explosion would likely ignite fires if any volatile materials existed on Mars's surface. The temperature could rise dramatically in the immediate area, causing localized, intense heat. The explosion would also release radiation which, even though Mars has no global magnetic field like Earth, might still be contained within the atmosphere, altering its composition and potentially leading to harmful UV radiation. But let's focus on a critical question. Could Mars's gravity actually attract 3I Atlas? Mars's gravity is weaker than Earth's, about 0.38 times the gravity of Earth. While this means Mars could influence smaller objects, 3I Atlas is too massive and moving too fast for Mars' gravity to pull it in. The hyperbolic trajectory that 3I Atlas follows, meaning it's not gravitationally bound to the Sun, ensures that no planet, including Mars, can change its path. It's traveling too fast and too far away from Mars's gravity well to be captured. Even if there was a slight perturbation in its path, the chances of it being drawn into Mars's atmosphere are incredibly slim. However, the fact remains that a collision with Mars is extremely unlikely, given that 3I Atlas is not on a collision course. Its trajectory ensures it will pass by the red planet at a safe distance. Now, what if 3I Atlas somehow managed to explode upon entering Mars's atmosphere? Given the thin atmosphere of Mars, this scenario seems unlikely, as it's not dense enough to slow down or ignite the object. However, if such an explosion were to occur, the consequences would be severe. The object's kinetic energy would be transferred to the Martian surface, causing a massive shockwave. The explosion could send debris flying across the planet and potentially create huge craters. The dust and debris would form a massive dust cloud, temporarily blocking out sunlight, which could disrupt the Martian weather and atmosphere for days, if not weeks. While Mars does have a thin atmosphere, it still offers some protection from radiation, and any explosion would likely generate intense UV radiation. This radiation could alter the chemical structure of the atmosphere, possibly even affecting its composition. What if this explosion had an even more disastrous impact on Mars's atmosphere? 3I Atlas has been classified as a dense rocky body, likely composed of carbon-rich materials. The explosion would send dust and gases into the Martian atmosphere, and some of these materials could potentially increase the overall dust storm activity on the planet. Given the current dust storms observed on Mars, the effects could be substantial, potentially altering the climate for months or years. What would happen on Earth if 3I Atlas collided with Mars or exploded? While 3I Atlas will be passing well beyond Earth's orbit, a direct impact with Mars could still have an indirect effect. Since Earth is about 0.5 AU away from Mars at this time, a large explosion or massive shockwave might create electromagnetic radiation that could briefly affect Earth's upper atmosphere. This could disrupt communications for a brief time, but the chances of direct effects are minimal. The object's sheer mass and speed mean that any residual effects would be short-lived and contained primarily within the Mars-Earth region. However, what if the explosion was more powerful? Could 3I Atlas's impact create a shockwave that would affect Earth, triggering disruptions in Earth's atmosphere or magnetic fields? While it's highly unlikely, such a possibility exists if the explosion was powerful enough. Still, the lack of significant gravitational interaction between Earth and Mars would likely prevent any large-scale impact on Earth's climate. If 3I Atlas were to explode or impact Mars, the data collected would be invaluable to scientists on Earth. A sudden collision or explosion would provide new insights into the composition of interstellar objects, as scientists would be able to study the debris, gases, and particles released into Mars' atmosphere. Additionally, the interaction between the object and Mars's thin atmosphere could provide a deeper understanding of how rogue objects from other star systems behave when they encounter planetary bodies. What would we learn from the impact or explosion? If 3I Atlas were to explode, we would likely gain valuable information about its composition and chemical makeup. With advanced spectrometers on Mars orbiters and rovers like Perseverance, scientists would be able to analyze the gases, dust, and chemicals released in the explosion. We could discover new compounds or learn about the building blocks of the universe, particularly those found in interstellar space. Additionally, the explosion or impact could provide key insights into planetary formation, particularly the formation of rogue bodies that travel between stars. If 3I Atlas had any volatile materials or compounds that were formed before our solar system came into existence, the data could illuminate the early stages of planetary and star system formation. Understanding how these objects from beyond our solar system behave when they come into contact with planets could give us a new perspective on the history of our solar system. Could interstellar objects have played a role in shaping our solar system in its early days? Even more intriguing, the shockwave created by the explosion could provide clues to how objects from outside our solar system interact with planetary atmospheres. Could interstellar bodies like 3I Atlas have impacted Earth's atmosphere in the past? The data from a Martian collision could potentially reshape our understanding of how solar systems, planets, and galaxies evolve. Path to perihelion on October 29th, 30 A's. The days tick down towards October 29th, 2025. 3I Atlas will be making its way closer to the Sun. This critical point in the comet's journey is known as perihelion, the point where the object will be closest to the Sun. It is during this time that 3I Atlas will experience the most intense solar radiation, causing it to undergo significant changes. The heat from the Sun will cause rapid sublimation of gases and dust from its surface, creating a spectacular tail and coma. The perihelion pass for 3I Atlas marks the culmination of its journey through our solar system, as it passes closest to the Sun and begins its outward journey again. This moment is particularly important because it allows scientists to study the effects of solar radiation on interstellar objects at their closest point to the Sun. We can anticipate dramatic changes in the object's tail and coma, making it a valuable moment for observation. At perihelion, 3I Atlas will likely experience a surge in outgassing, especially from the volatile compounds within its icy nucleus. The nuclear activity at this point will give astronomers insights into its chemical composition, revealing how the comet interacts with solar heat. This information will help us understand the chemical diversity of interstellar objects and how they evolve as they journey through space. The temperature at perihelion will cause significant sublimation of materials like carbon dioxide, CO2, and cyanide, CN. And as we know from prior observations, these gases will mix with the comet's dust, creating its characteristic coma. During this time, scientists will be closely monitoring 3I Atlas using telescopes like NASA's Hubble Space Telescope and the James Webb Space Telescope, JWST. The focus will be on understanding how much material is being lost, the composition of the tail, and whether new volatiles are being emitted as it gets closer to the Sun. Moreover, this period will provide an opportunity to track 3I Atlas as it interacts with solar winds, which may reveal new insights into how objects from outside our solar system behave when subjected to the Sun's intense energy. For the first time, we will have a clear understanding of how an interstellar object reacts to our solar environment at close range, with implications for our understanding of solar system dynamics and the movement of cosmic objects. While October 29-30 represents the peak of 3I Atlas's interaction with the Sun, it is by no means the final interaction with objects in the solar system. Following perihelion, the comet will continue its journey beyond the Sun, with future close encounters set to occur with several major planets in the solar system. After perihelion, 3I Atlas will head toward the outer reaches of the solar system. Its trajectory will bring it near Venus, Earth, and Jupiter, although it will remain at a safe distance from these planets. The comet's path will give scientists the opportunity to study its motion and any possible gravitational interactions with these planets. The Earth encounter is particularly interesting, as it will provide a more stable and predictable point of study. While 3I Atlas will pass far enough away that Earth will not be affected, the close proximity of this object offers an opportunity to test models of gravitational assists in interstellar object studies. The gravitational effect that Venus, Earth, and Jupiter may have on 3I Atlas will allow scientists to measure how such massive bodies interact with objects moving at such high speeds. These encounters can provide further insights into the velocity, trajectory, and trajectory corrections that come into play as 3I Atlas exits our solar system. The encounter with Jupiter will also be an essential test for interstellar object theory. The massive gravitational pull of Jupiter could, in theory, alter the path of the comet ever so slightly, depending on the angle of the encounter. As 3I Atlas passes Jupiter's orbit, it may experience a gravitational deflection that shifts its trajectory and speed, potentially causing a significant change in its velocity as it exits the solar system. This deflection may provide critical data on the dynamics of interstellar objects, helping to refine our models of how objects move through the galaxy. The interactions with Jupiter's gravity will be a final test of how effectively interstellar objects can alter their paths in a predictable manner. 3I Atlas will be a game changer for interstellar object studies and could revolutionize our understanding of cosmic bodies from beyond our solar system. Its study is particularly important because it provides real-time data on the characteristics and behaviors of objects that have traveled across vast distances from other star systems. Interstellar objects like 3I Atlas offer new opportunities to study the formation of stars, planets, and solar systems in ways we couldn't before. This comet is the first interstellar object detected since Oumuamua in 2017. But unlike Oumuamua, which had an elongated shape, 3I Atlas displays comet-like features. Studying its chemical composition, speed, tail, and trajectory will allow scientists to understand how these objects are born, evolve, and ultimately travel across the vast distances of the cosmos. One of the most exciting aspects of studying 3I Atlas is the fact that it is likely made up of material that predates our solar system. Objects like this could contain clues about the chemical composition of the early universe, long before the formation of stars and planets. For example, we may learn more about the dust grains and gases that formed early star systems and how they helped give rise to planets, moons, and other cosmic bodies. By comparing 3I Atlas's properties with other solar system comets, scientists will gain deeper insights into the chemical evolution of celestial bodies and their potential to harbor volatile compounds like water, carbon, and organic molecules. This could shed light on the potential for life beyond Earth, and whether interstellar bodies like 3I Atlas might have the necessary elements to support life, either in our solar system or in another star system. In short, 3I Atlas will serve as a Rosetta Stone for studying rogue bodies. It will enable researchers to refine their understanding of how planets, stars, and solar systems form and evolve. The study of interstellar objects could eventually lead to new breakthroughs in planetary science, astrophysics, and extraterrestrial life studies. While 3I Atlas's flyby of Mars holds a wealth of scientific significance, it also offers a unique opportunity to tie into the broader narrative of human exploration of Mars. With NASA and ESA currently leading missions to study the Red Planet, including Mars 2020 and ExoMars, the data we gather from 3I Atlas will enhance our understanding of not only Mars itself, but also the broader goals of human exploration. This comet's passage offers new insights into Mars's atmosphere, its surface characteristics, and its magnetic environment. Any ion or gas releases from 3I Atlas could help scientists study how the Martian atmosphere responds to external influences from objects passing nearby, particularly those from beyond our solar system. It is a test of Mars' ability to retain an atmosphere in the face of external forces, vital data for future human missions to Mars, where understanding its environmental interactions will be key. Additionally, any radiation, plasma, or dust interactions caused by the flyby could provide insights into Mars's habitability and its potential to support human life. While 3I Atlas will not collide with Mars, its flyby could serve as a small-scale simulation for future interplanetary missions where spacecraft, rovers, or even humans will need to prepare for the unknown forces exerted by interstellar bodies. As human missions to Mars ramp up, especially those by NASA, SpaceX, and other agencies, 3I Atlas's passage is a reminder of the importance of interstellar object monitoring. It's a precursor to future missions that may need to protect Mars from potential hazards, whether from space debris or other objects on similar trajectories. We have learned a bit about 3I Atlas. Its unusual behavior and composition have raised many questions. But before we dive deeper into what makes it so unique, let's take a step back. What if we compared it to the two previous interstellar objects that have passed through our solar system, Oumuamua and 2I Borisov? These two objects brought their own sets of mysteries, each unveiling something new about the cosmos. And now, 3I Atlas joins the ranks, adding to the puzzle. In 2017, Oumuamua, the first interstellar object ever detected, appeared out of nowhere, sparking intrigue across the scientific community. Its elongated, cigar-like shape and erratic behavior led to wild speculation. Was it just a natural object, or was it something more? Some even proposed that it could be an artificial probe sent by an advanced civilization. Then, in 2019, 2I Borisov arrived. Unlike Oumuamua, Borisov was a more typical comet, familiar in its appearance and behavior. Its predictable tail and clear signs of outgassing allowed scientists to study it in ways that were impossible with Oumuamua. It was a relief of sorts, a chance to study something we understood more thoroughly, but its presence still raised the same fundamental questions. What does the arrival of an interstellar object tell us about the nature of our galaxy? Now, 3I Atlas enters the scene. A comet traveling faster than anything we've ever observed. Its trajectory and composition seem to blur the lines between the familiar and the extraordinary. It's been compared to both Oumuamua and Borisov, but it's clear that it doesn't fit neatly into either category. So what makes 3I Atlas so different? What can we learn from comparing it to these two interstellar visitors? Let's first take a closer look at Oumuamua and its mysterious features. When it was discovered in 2017, it was like nothing we had ever seen. The object's strange, elongated shape and rapid speed baffled scientists, who initially thought it was an asteroid or comet passing through the solar system. But there were no signs of outgassing, the typical behavior of a comet, leading some to speculate that it might be artificial. This sparked heated debates among scientists, including renowned astrophysicist Avi Loeb, who proposed that Oumuamua could be an alien spacecraft sent to observe our solar system. Then, in 2019, 2I Borisov arrived. Unlike Oumuamua, Borisov was a more typical interstellar comet. It had a visible tail, which was a clear sign of outgassing, and its behavior was much more predictable. Scientists were able to study Borisov in great detail, analyzing its composition and trajectory as it passed through our solar system. However, despite its normality, it still carried the mystery of being an interstellar object, offering us a glimpse into the outer reaches of our galaxy. I Atlas, discovered in 2025, shares similarities with both of these objects, but also stands apart in significant ways. Like Oumuamua, 3I Atlas is traveling at an incredibly high speed, making its approach unique. However, unlike Oumuamua, which exhibited strange acceleration and lacked typical cometary behavior, 3I Atlas shows signs of being more like a comet. It has a tail and displays some of the expected behaviors of a comet, yet its composition, particularly the high amount of nickel and low levels of iron, raises eyebrows. This has led some to speculate that 3I Atlas might not be just another comet from a distant star system, but something more. Comparing these three objects highlights the diversity of interstellar objects and challenges our understanding of what lies beyond our solar system. Is 3I Atlas just another natural phenomenon, or does it represent something new, something beyond our current scientific understanding? Each of these objects presents a different facet of interstellar science, and by studying them, we begin to unlock the secrets of other star systems. Let's break down the key differences and similarities between 3I Atlas, Oumuamua, and Borisov. First, in terms of speed, 3I Atlas is moving faster than both Oumuamua and Borisov, with a speed of around 27 kilometers per second. This high velocity is one of the reasons why it will not return to our solar system after its flyby. In contrast, both Oumuamua and Borisov were on trajectories that would have brought them back to the solar system after their initial pass, although they would take thousands of years to return. In terms of composition, 3I Atlas is a bit of an anomaly. While Oumuamua's composition was never directly confirmed, it was suggested that it might be a metal-rich object. Borisov, on the other hand, was a more traditional comet with a clear tail made up of dust and gas. 3I Atlas, however, has a high amount of nickel, but no detectable iron. This unusual composition, combined with its high speed, has led some to question whether it could be an artificial object, a theory similar to the one proposed for Oumuamua. In terms of behavior, 3i Atlas shows both comet-like characteristics and some unusual features that set it apart from other interstellar objects. Its high velocity and unusual composition raise questions about its origin and its true nature. Could it be a probe sent by an advanced civilization? Or is it just an unusually structured comet from a distant star system? Only time and further study will reveal the answer. The comparison of 3i Atlas with Oumuamua and Borisov highlights the mystery of interstellar objects and the potential they hold for answering some of the biggest questions in astronomy. By studying these objects, we can learn more about the nature of other star systems, the formation of planets, and the possibility of life beyond our solar system. Each of these objects provides a piece of the puzzle, and as we continue to observe and analyze them, we move closer to understanding the true nature of the universe and our place in it. While 3i Atlas may not have the same bizarre qualities as Oumuamua, or the more predictable behavior of Borisov, it stands as an important discovery in its own right. It challenges our understanding of interstellar objects and gives us a glimpse into the mysteries that lie beyond our solar system. Could it be the key to unlocking new questions about the origins of life in the universe? Only time will tell, but the journey to uncover the truth about 3i Atlas is sure to be one of the most exciting chapters in the history of space exploration. Mars, often referred to as the Red Planet, stands as one of the most intriguing bodies in our solar system. Known for its striking red appearance, which is a result of the iron oxide-rich surface, Mars has captivated astronomers, scientists, and space enthusiasts for centuries. As the fourth planet from the Sun, Mars lies in the so-called Goldilocks zone, where conditions might have once been right for life to emerge, though it is, of course, far colder and drier than Earth. Understanding Mars is crucial for a variety of reasons. It can offer insights into the evolution of our solar system, the history of planetary habitability, and the future of human exploration beyond Earth. Mars represents a tantalizing opportunity to study the building blocks of life, planetary processes, and to possibly pave the way for future human exploration. As we look deeper into its features, history, and the possibilities it holds for the future, Mars stands as a critical target for space exploration. Mars has a thin atmosphere that is drastically different from Earth's, comprised mainly of carbon dioxide, with traces of nitrogen, argon, and oxygen. This atmosphere is only about 1% the thickness of Earth's. The thinness of Mars' atmosphere means that it lacks the protective qualities that Earth's atmosphere offers, making the surface vulnerable to intense solar radiation and cosmic rays. This lack of a thick atmosphere also means that the planet has little to no ability to trap heat, contributing to its cold surface temperatures. Without the protective shield of a strong atmosphere, the planet's ability to support life as we know it is severely limited. The thin atmosphere also plays a significant role in the planet's weather patterns, or rather, its lack of them. Mars experiences dust storms, some of which are planet-wide, but the atmosphere doesn't allow for the same kinds of weather systems found on Earth. These dust storms can change the planet's climate temporarily, making it difficult to study long-term patterns. Mars is cold, extremely cold. The average surface temperature is about 60 degrees, 80 degrees. However, temperatures can swing dramatically from 125 degrees, 195 degrees at the poles during the Martian winter to a much more temperate 20 degrees, 168 degrees at the equator during the Martian summer. This variance in temperature occurs because Mars has a relatively thin atmosphere, which doesn't allow it to retain heat effectively. Mars's surface is also incredibly dry, with little to no liquid water remaining. However, scientists believe that Mars may have once had flowing rivers, lakes, and even an ocean. Evidence of ancient riverbeds, dried-up lake basins, and mineral deposits suggest that Mars once had a much more hospitable climate, a stark contrast to the cold, dry planet we observe today. Similar to Earth, Mars experiences seasons. However, due to the planet's longer orbit around the Sun, Martian years are almost twice as long as Earth years, 687 Earth days to be exact. The length of a Martian day, or sol, is just a little over 24 hours, making Mars's daily cycle similar to Earth's. However, because of its elliptical orbit, the seasons on Mars are much more extreme than on Earth. For example, the planet's southern hemisphere experiences hotter summers and colder winters than the northern hemisphere due to Mars's axial tilt. The longer seasons mean that atmospheric changes take place over a much slower timescale, affecting the evolution of the planet's surface and climate. Mars is home to some of the most fascinating geological features in the solar system, making it a prime target for exploration. The most notable of these is Olympus Mons, the largest volcano in the solar system, standing nearly 3 times the height of Mount Everest. This giant shield volcano is thought to have been dormant for millions of years, but its size indicates that it likely erupted many times in the distant past. Another key feature is Valles Marineris, a massive canyon system that dwarfs the Grand Canyon, stretching over 4,000 kilometers long, up to 200 kilometers wide, and about 7 kilometers deep. Valles Marineris is believed to have formed due to tectonic forces, with the Martian crust pulling apart. This giant rift system is a testament to the immense geological activity that once shaped Mars's surface. In addition to these, Mars also has polar ice caps made up of water and dry ice, frozen CO2. These polar ice caps grow and shrink with the changing seasons and are a key indicator of the planet's atmospheric cycles. Understanding the ice caps is important for determining the planet's past climate and its potential for supporting life. Mars. Exploration history. The exploration of Mars has been a key objective for space agencies around the world, beginning with flybys and orbiters, and later progressing to landers and rovers. Mars has been studied from a variety of angles. Each mission has revealed more about the planet's geology, atmosphere, and potential for past life. Mars rovers. Mars rovers have been pivotal in providing detailed information about the planet's surface. Early missions, such as the Spirit and Opportunity rovers, set the stage for understanding the geology of Mars. These rovers, which spent years exploring the Martian surface, discovered evidence of past water activity, including rocks that had been altered by water. The Curiosity rover, which landed on Mars in 2012, built upon this knowledge by investigating the planet's ability to support life. Curiosity has discovered a variety of organic molecules and methane, which could indicate the potential for microbial life in Mars's past. Most recently, the Perseverance rover landed on Mars in February 2021 and is continuing the search for signs of ancient life. It is also tasked with collecting samples that could one day be returned to Earth for analysis. Perseverance is also exploring the Jezero crater, a site thought to be the location of an ancient Martian lake. Mars orbiters have played a crucial role in understanding the planet from above. Missions such as Mars Express, ESA, Mars Reconnaissance Orbiter, NASA, and ExoMars Trace Gas Orbiter have provided high-resolution images of the Martian surface and gathered data about the planet's atmosphere and weather patterns. These orbiters have identified features such as ancient riverbeds, seasonal changes in the polar ice caps, and atmospheric dust storms. Mars has long been considered a candidate for past microbial life. The evidence of dried-up riverbeds, ancient lake basins, and methane spikes suggests that Mars may have been a more habitable place in its distant past. While there is no direct evidence of life on Mars, scientists are hopeful that future missions could uncover signs of microbial life or even subsurface water. The potential for life on Mars has driven much of the exploration efforts, and it remains a key question for future studies. As the date of October 3rd, 2025 approaches, the celestial event of the year is unfolding in the vast reaches of our solar system. 3I Atlas, a comet-like interstellar wanderer, is on its trajectory toward a flyby of Mars. For scientists, this isn't just another comet passing through the solar system. This is a rare opportunity to study both the comet and the planet Mars in unprecedented detail. The flyby promises not just to provide new insights into 3I Atlas's nature, but also to enhance our understanding of the Martian atmosphere, weather, and magnetic field interactions. Mars has long captivated scientists as a target for exploration, not just because it holds clues about the history of our solar system, but also because it may hold secrets about past life. However, the Martian atmosphere is still largely a mystery. Thin, dry, and harsh. The flyby of 3I Atlas could provide just the kind of environmental shock needed to reveal hidden dynamics that might not have been apparent through traditional methods of observation. In the following segments, we'll break down what we can expect from this fascinating encounter. For all its mysteries, 3I Atlas is much more than a visitor from another star system. Its passing by Mars offers a rare window into not just the comet's composition and behavior, but also how its physical attributes interact with the Martian atmosphere. The unique nature of 3I Atlas, being the third confirmed interstellar object to pass through our solar system, provides scientists with an exceptional opportunity to observe how such an object behaves when in close proximity to a planetary atmosphere. Mars, with its thin, mostly CO2 atmosphere and lack of a global magnetic field, is uniquely vulnerable to any external influences. As 3I Atlas makes its close approach, we can observe how its high-speed passage at over 27 km/s might affect the Martian environment in ways that previous comets or asteroids have not. Given its size, estimated at around 33 billion tons, and its speed, the comet's passage could have subtle but significant effects on Mars's atmosphere and the ionosphere. By observing how Mars responds to 3I Atlas's approach, scientists can refine existing models of planetary interaction with interstellar objects, and more importantly, learn how objects like 3I Atlas influence atmospheric dynamics. This encounter, though fleeting, will give us a clearer picture of how other planetary atmospheres could behave in the face of such external objects. Whether they are comets, asteroids, or even rogue planets, Mars's weather system is an enigma in many ways. Unlike Earth, Mars has no oceans or large bodies of liquid water to drive weather systems. It has a thin, CO2-dominant atmosphere, and its surface conditions are cold and dry, with an average temperature of about 60 degrees C. Despite this, Mars is known for dust storms, some of which are planet-wide, capable of enveloping the entire planet in a haze for weeks or months. These dust storms can have significant impacts on Martian weather and may even affect global temperature patterns. As 3I Atlas approaches Mars, one of the most significant factors in play will be how the comet's tail, a mixture of gas and dust, interacts with the Martian atmosphere. The high-speed passage of 3I Atlas could induce localized disturbances in Mars' thin atmosphere, potentially altering weather patterns in unexpected ways. First, we know that 3I Atlas's tail, which is made up of gases like carbon dioxide, hydrogen cyanide, and dust particles, will likely interact with Mars' atmosphere. As the comet moves closer to Mars, the amount of gas and dust streaming from the tail could increase. While Mars lacks an Earth-like climate system, the dust and gas emitted from the comet might still influence the Martian atmosphere, creating minor changes in temperature or pressure. The impact on the planet's already tenuous weather systems could be brief but interesting. The real excitement lies in what happens when the comet's tail passes through Mars' atmosphere. As 3I Atlas approaches its closest pass, scientists will be watching closely for any signs that the comet's tail interacts with the Martian air, potentially triggering changes in wind patterns or dust distribution. When it comes to Mars, the absence of a protective magnetic field makes the planet susceptible to the solar wind and cosmic radiation. The fact that 3I Atlas is carrying a tail of gas and dust, which will likely increase in size as it approaches the Sun, adds a layer of complexity to understanding the flyby's effects. Mars' atmosphere could be disturbed by these interactions, leading to possible auroral events or ionization within its thin atmosphere. The interaction between 3I Atlas's tail and Mars's atmosphere could also contribute to ionization, especially since Mars lacks a global magnetic shield. The comet's tail could create localized disturbances, potentially initiating changes in the Martian ionosphere. The ions could cause auroras, similar to the auroras we see on Earth, though they would likely be faint and localized due to the planet's lack of a strong magnetic field. When considering the comet's tail, it's essential to understand the potential effects on Mars' ionosphere. As 3I Atlas moves closer to Mars, the energy released from its tail might ionize some particles in the Martian atmosphere. This could result in a small but measurable increase in atmospheric ionization levels. Given that Mars's atmosphere is so thin, the effects will be much less dramatic than on Earth. But there's still potential for measurable effects that could give scientists insight into how interstellar objects interact with planetary atmospheres. Mars has long been a target of study for its vulnerability to cosmic radiation and solar wind. Unlike Earth, which is protected by its magnetic field, Mars' thin atmosphere and lack of global magnetosphere make it highly susceptible to the harsh conditions of space. The flyby of 3I Atlas could significantly increase the risk of ionized particles interacting with Mars' atmosphere, though not in a way that would create immediate harm. The increased number of particles coming from the comet could trigger ionization within the atmosphere, causing changes in the chemistry of Mars' air. Such changes could help scientists understand how Mars reacts to external objects and cosmic events. One important area of study during the 3I Atlas flyby is the relationship between the comet's tail and the ionization of Mars' atmosphere. As the comet moves through the solar system, its gas and dust will continue to interact with the planet's atmosphere. Scientists are particularly interested in observing how the solar wind from 3I Atlas affects the upper layers of Mars' atmosphere, where it might trigger secondary ionization effects. These interactions could provide critical insights into the planet's ability to withstand external influences, including potential challenges to habitability for future missions. Given Mars's susceptibility to ionizing radiation, scientists will also monitor how the ionized particles from 3I Atlas's tail might alter the atmosphere and how they might interact with Mars's surface. Any unexpected findings from these interactions will enhance our understanding of planetary defense systems and how planetary bodies cope with external forces in space. The flyby of 3I Atlas, set for October 3, 2025, is much more than a study of an interstellar object. It's a rare opportunity for scientists to learn about the intricate dance between interstellar objects and planetary bodies, such as Mars. As the comet makes its way through the solar system, scientists will continue to monitor Mars' weather, atmosphere and ionosphere for any sign of changes. Mars' unique vulnerability, its thin atmosphere, lack of a magnetic field, and exposure to the harsh conditions of space makes it an ideal candidate for studying the effects of interstellar objects. The scientific community is prepared for an exciting few weeks ahead. From understanding how the Martian weather systems will respond to the comet's approach, to studying how Mars' atmosphere interacts with the tail, the 3i Atlas flyby will unlock new insights into both the planet and the object itself. The data collected will not only help us understand how 3i Atlas interacts with the planet, but also provide critical insights into planetary resilience and defense systems. The discovery of 3i Atlas, a comet-like object traveling through our solar system, has sparked intense debates and speculative theories about its origins and purpose. What makes this object particularly intriguing is not just that it is the third interstellar object ever detected, but also the unusual characteristics it exhibits. Some scientists are asking whether 3i Atlas could be a probe or artifact sent by an advanced alien civilization, and if so, what it could mean for our understanding of extraterrestrial intelligence and the broader question of life beyond Earth. The concept of interstellar probes is not new. For decades, scientists have speculated that alien civilizations, if they exist, might send probes to explore distant star systems, much like our own space agencies have sent spacecraft to explore the planets of our solar system. The idea that 3i Atlas could be one such probe, sent to observe our solar system or even to make contact with us, is both fascinating and unsettling. Could 3i Atlas be a message from the stars? Let's explore this question by examining the characteristics of the object itself and the theories surrounding its potential as a probe, the science behind 3i Atlases, composition and behavior. One of the primary reasons why 3i Atlas has sparked such intense interest is its highly unusual behavior and composition. Unlike most comets, which follow predictable orbits and exhibit common features such as a tail made of gas and dust, 3i Atlas appears to defy expectations. It is traveling at an incredible speed, much faster than most objects in our solar system, and it follows a hyperbolic trajectory, meaning it will not return to our solar system after it passes through. The high velocity of 3i Atlas is one of the key features that make it stand out. It is moving at a speed of approximately 27 km/s relative to Mars during its closest approach. This is much faster than typical comets, which generally move at speeds between 10 and 20 km/s. The speed of 3i Atlas suggests that it is not bound by the Sun's gravity and is merely passing through our solar system on its journey across the galaxy. This means that it is an interstellar object, not something that has been captured by the Sun's gravitational pull. The idea that 3i Atlas is from another star system adds to the mystery surrounding its origins and potential purpose. In addition to its speed, the composition of 3i Atlas is also highly unusual. Spectroscopic observations of the object have revealed that it contains a high concentration of carbon dioxide, CO2, a volatile gas that is commonly found in comets. However, 3i Atlas also contains an unusually high amount of nickel, a metal that is rarely found in natural comets. Nickel is more commonly associated with metal-rich asteroids or even human-made objects. The presence of nickel in 3i Atlas raises intriguing questions about the nature of the object. Could it be the result of natural processes, or does its composition suggest something more artificial in origin? Another strange feature of 3i Atlas is its behavior. Most comets exhibit a relatively predictable pattern of outgassing, where gases are expelled from the nucleus of the comet, creating a tail that always points away from the Sun. However, 3i Atlas has exhibited some unusual behavior in this regard. Some scientists have reported that the comet's tail appears to be asymmetric, with jets of gas emanating from different parts of the object. This could suggest that 3I Atlas is not behaving like a typical comet, and could indicate that it is being influenced by factors other than the sun's radiation, such as internal mechanisms or external forces. All of these unusual characteristics, its high speed, its unusual composition, and its odd behavior, have led some scientists to speculate that 3I Atlas could be more than just a comet. Could it be a probe sent by an advanced alien civilization to observe our solar system, or even to make contact with us? If so, what could this mean for our understanding of extraterrestrial intelligence? Arguments for 3I Atlas being a probe. The theory that 3I Atlas could be a probe sent by an alien civilization is a fascinating one, and it is not without merit. There are several arguments that support this theory, based on the object's unusual behavior and composition. First, the high speed of 3I Atlas is a key factor that has led some scientists to speculate that it could be artificial. As mentioned earlier, the object is traveling much faster than typical comets, which suggests that it is not bound by the sun's gravity and is simply passing through our solar system. Some have argued that this high speed could be the result of some kind of propulsion system, such as a drive or engine, which would be consistent with the idea that 3I Atlas is a probe. Second, the presence of nickel in 3I Atlas is another point in favor of the probe theory. As mentioned earlier, nickel is rarely found in natural comets, and its presence in 3I Atlas raises the possibility that the object could be artificial. Nickel is commonly used in the construction of spacecraft and other technological devices, and it is conceivable that an advanced alien civilization could have sent a probe made of materials that contain nickel. The high concentration of nickel in 3I Atlas could be a sign that the object was intentionally constructed or engineered, rather than being a naturally occurring comet. Finally, the strange behavior of 3I Atlas, particularly the asymmetric tail, has led some scientists to suggest that it could be a probe or artifact sent by an advanced civilization. Unlike most comets, which have a predictable pattern of outgassing, 3I Atlas seems to have jets of gas emanating from different parts of the object. This could suggest that the object is being influenced by some kind of internal mechanism, such as a propulsion system or energy source, rather than just the sun's radiation. In addition, the very fact that 3I Atlas is traveling from outside our solar system adds weight to the theory that it could be a probe sent to observe our solar system. The object's interstellar origin suggests that it could be part of a mission to explore distant star systems, much like how our own space agencies send probes to explore other planets and moons in our solar system. If 3I Atlas is indeed a probe, it could be part of a larger effort to explore the galaxy and possibly make contact with other civilizations. Arguments against 3I Atlas being a probe. While the idea that 3I Atlas could be a probe is intriguing, there are also several arguments against this theory. Some scientists believe that the object's unusual behavior and composition can be explained by natural processes, rather than the influence of an advanced civilization. First, the high speed of 3I Atlas could simply be the result of its hyperbolic trajectory, rather than any artificial propulsion system. The object is not bound by the sun's gravity, meaning that it is simply passing through our solar system on its way through the galaxy. The high speed is a result of the object's motion relative to the sun, and it is not necessarily indicative of any kind of propulsion system. Second, the presence of nickel in 3I Atlas could be explained by natural processes as well. Some scientists have suggested that the object could be a fragment of a larger body, such as a metal-rich asteroid or a planetesimal, that was ejected from its original star system. The high concentration of nickel could be the result of the object's composition, rather than any artificial design. Finally, the strange behavior of 3I Atlas could simply be the result of natural forces acting on the object. The asymmetry in the comet's tail could be caused by the sun's radiation pressure acting unevenly on the object. Or it could be due to other natural processes, such as outgassing from different parts of the nucleus. There may be no need to invoke artificial influences to explain these phenomena. In the end, the true nature of 3I Atlas remains uncertain. While there are compelling arguments for and against the idea that it could be a probe sent by an alien civilization, the object's unusual characteristics make it a fascinating subject for further study. As we continue to observe 3I Atlas and gather more data, we may eventually find the answers to these questions. For now, however, the mystery of 3I Atlas continues to fuel the imagination of scientists and the public alike, sparking curiosity and speculation about the possibility of life beyond our solar system. As 3I Atlas travels through our solar system, it presents an unprecedented opportunity to explore the broader question of life's existence beyond Earth. While many view 3I Atlas as just another interstellar object passing through, its presence also opens a doorway to deeper discussions about the possibility of life elsewhere in the universe. Could the materials and chemicals found in 3I Atlas be similar to those found on exoplanets that could harbor life? Could this object, in its essence, be a messenger from the stars, telling us something vital about the conditions necessary for life in the cosmos? The connection between 3I Atlas and the search for life extends beyond mere speculation. The materials found in the comet could offer us invaluable insight into the building blocks of life. By understanding its composition, we may gain clues about the chemical elements necessary for life to emerge on other planets. This is important not only for 3I Atlas, but also for the ongoing search for habitable exoplanets like Proxima b or Kepler 4522b, which are prime candidates for supporting life. What if the materials found in 3I Atlas are similar to those on these exoplanets? Does it suggest that life is common across the universe? Or that the very building blocks of life could be scattered across the stars, waiting for the right conditions to spark the creation of life? The search for life on other planets often focuses on finding the right conditions for life to exist. Scientists look for habitable zones, or regions where conditions are favorable for liquid water to exist. These zones are critical for life as we know it, because water is essential for all life forms we understand. But what if life could exist in places we don't yet understand, such as on planets orbiting red dwarf stars or in extreme environments like methane lakes on Titan, Saturn's moon? In the case of 3I Atlas, it is traveling across interstellar space, potentially bringing with it the building blocks of life that could provide new insights into the conditions necessary for life to exist on exoplanets. The key question here is, can we trace the chemical signature of life in materials from interstellar space? And if so, what does this mean for our search for habitable planets? While the materials on 3I Atlas are unlikely to contain complex life forms, they may hold essential organic compounds, amino acids, or simple molecules that are the precursors to life. Studying these materials could help us understand how life may emerge under different conditions. A critical point to consider is the composition of 3I Atlas. The presence of carbon dioxide, water ice, and other molecules commonly associated with life has sparked further speculation about whether 3I Atlas's composition is indicative of the kinds of environments where life might flourish. If similar compounds can be found on exoplanets, it might suggest that the conditions for life, while potentially different from Earth, are more widespread across the galaxy than previously imagined. One of the most intriguing theories about the origin of life on Earth is the idea of panspermia. According to this hypothesis, life may have originated elsewhere in the universe and was transported to Earth on comets, asteroids, or other celestial bodies. The idea of panspermia has been around for centuries, but recent discoveries, including 3I Atlas, have given the theory new life. The presence of organic materials and amino acids in comets and meteorites found on Earth has led some scientists to suggest that the building blocks of life may have been carried to our planet on interstellar objects. In this context, 3I Atlas could be an important piece of the puzzle. If 3I Atlas contains materials that are essential for life, such as carbon-based molecules or other complex compounds, this would strengthen the idea that life on Earth could have originated from interstellar dust or particles carried by comets. The fact that 3I Atlas is from outside our solar system raises the possibility that similar objects could be traveling throughout the galaxy, carrying the basic ingredients of life. These objects could be providing new information about how life could spread across the universe, potentially seeding planets like Earth with the materials needed for life to develop. Atlas's tail, composed of gas and dust, holds many clues that could help us understand the conditions for life in the universe. Scientists are particularly interested in the composition of the coma, the cloud of gas and dust surrounding the nucleus of the comet, and the tail. This tail is not just an aesthetic feature. It is a collection of material that has been ejected from the nucleus due to solar heating and other forces. By studying the tail, scientists can learn about the physical and chemical processes that have shaped 3I Atlas. During its journey through the cosmos, the tail of 3I Atlas could potentially provide essential information about the early stages of planetary and molecular formation. Organic compounds, including simple sugars, amino acids, and other complex molecules, have been detected in cometary dust particles. These compounds are often considered to be the building blocks of life. If 3I Atlas's tail contains similar materials, it would further support the idea that comets and interstellar objects play a significant role in the chemical evolution of the galaxy. These materials could have been transported from distant regions in space, potentially contributing to the formation of life on Earth or other planets. The detection of these complex organic molecules in 3I Atlas would not only advance our understanding of the origins of life on Earth, but also shed light on the broader question of whether life exists elsewhere in the universe. If similar molecules are found on exoplanets in habitable zones, it would suggest that life could exist in those regions as well. The connection between 3I Atlas and the search for life on exoplanets becomes even more critical when considering that comets are thought to have contributed to the formation of Earth's oceans and the development of its atmosphere. Therefore, understanding the composition of 3I Atlas and its tail could provide critical insights into how planets like Earth form and how life can arise. Atlas's visit is not just about understanding the nature of this particular object. It is also a stepping stone toward understanding the broader question of life in the universe. By studying 3I Atlas and other interstellar objects, scientists hope to refine their models for what makes a planet habitable and what conditions are necessary for life to thrive. In the search for habitable exoplanets, 3I Atlas provides a unique lens through which to view the possibility of life beyond Earth. The presence of complex organic molecules in the tail of 3I Atlas could provide critical evidence that the building blocks of life are widespread in the galaxy. This would suggest that planets like Proxima b, Kepler 452b, and other exoplanets in habitable zones could potentially harbor life, given the right conditions. The discovery of 3I Atlas and the knowledge gained from studying its composition and behavior could lead to new discoveries. In the search for extraterrestrial life, one of the most exciting implications of studying 3I Atlas is the potential to refine our understanding of how life could survive and even thrive in environments vastly different from Earth. As our technology advances, scientists will be able to detect exoplanets with even more precision. and they will be able to analyze their atmospheres, compositions, and potential for life with unprecedented accuracy. This could bring us one step closer to answering one of the most profound questions humanity has ever asked. Are we alone in the universe? The study of 3I Atlas has the potential to unlock a deeper understanding of the origins of life in our solar system and beyond. By studying the composition of interstellar objects like 3I Atlas, scientists will gain insights into the materials that make up the universe, and how those materials may contribute to the creation of life on planets like Earth. The idea of panspermia, the theory that life might have originated elsewhere in the universe and been transported to Earth on comets or asteroids, gains weight in the context of 3I Atlas, which could represent a cosmic messenger of life. Ultimately, 3I Atlas provides us with a valuable opportunity to study the chemical building blocks of life and to refine our understanding of the potential for life elsewhere in the universe.